So let us just continue with talking about the number of protons and number of neutrons in a given element. So I have told you that the number of protons, which is also called the atomic number of an element, is what determines the type of element or the name of the element, right? The element itself actually. So if something has, let's say, 2 protons, I have 2 protons in the nucleus, this thing, and let's say I'll just put in 2 electrons also to make it electrically neutral. This thing would be called a helium atom, right? Because I have 2 protons, as simple as that. But I also told you that I can add I can have 1 neutron or maybe even 2 neutrons. Still this would be called a helium atom because it has 2 protons. But now there's a simple question here, a simple question arises here, is that by removing a neutron, I'm obviously changing something in this atom. So I mean, does that affect the atom's properties? Does that affect the element's properties? Well, the basic answer is yes and no, both. I'll explain that. When you change the protons, the number of protons, only then will you be changing the type of element or the name or the element itself. So let's say if I remove one of the protons from a helium atom, it becomes a hydrogen atom. So by doing this, I am changing the element itself. But if I don't change the number of protons, I only remove a neutron, that will not affect the chemical properties of that particular atom. It will still behave just like helium. Obviously the mass of the atom will be lighter because I have removed a particle which had a mass of 1 unit equal to the mass of protons, of 1 proton. So I have removed that, so the atom as a whole becomes lighter. So yeah, if now I have, let's say, 2 particles, 2 atoms, both have 2 protons, but let's say this one has only 1 neutron, this one has 2 neutrons, and let's just put in the electrons there. Let's say this has 1 electron, second electron, first electron, second electron. Yeah, how are these 2 different? Well, both of them are helium atoms, but they are only different in their mass, right? This atom is heavier, this one is lighter, but chemically both of them will behave in the exact same manner. So yeah, but we'll be looking at that in later modules, why they act in the same way chemically, but they'll be different, they'll have different masses. And what do we call such atoms? Well, these are called isotopes. Isotopes, that's one word. So these are called isotopes, and because they have 2 protons each, they'll be called helium isotopes. So this is the first isotope of helium, this is the second isotope of helium. Similarly, if I have only 1 proton in the center, so let me just put in the proton here. Because these 2 atoms have only 1 proton each, they'll be called hydrogen isotopes. But let's say this one has a neutron also and this one has no neutrons, so obviously they'll have different masses, and these 2 will be called hydrogen isotopes. The first hydrogen isotope, this is the second hydrogen isotopes. And to give you the technical definition of it, isotopes are those atoms that have the same atomic number. They are the same atomic number, right? 1 1 each. They have the same atomic number but different atomic mass. Now what is atomic mass? Let me just quickly introduce that too. Atomic mass, that is nothing fancy, it is simply the mass of your atom, as simple as that. So there are 2 terms to be kept in mind here: atomic number, that's visible, yeah. So there are 2 numbers to be kept in mind: atomic number and an atomic mass. Atomic number is the number of protons, I'll write that as P, and atomic mass, well, you can guess, is simply the number. So we'll just assume that 1 proton has a mass of 1 unit for now, so it is simply the number of protons plus neutrons. As simple as that. Now what is the atomic number of both of these? Well, this has an atomic number of, so it has only one proton, so its atomic number is 1. On the other hand, this has only one proton, so even it has an atomic number of 1, but the atomic mass of this one would be 1 plus 1, 2, right? So its atomic mass would be 2 units, and its atomic mass, I have only one particle inside the nucleus, so its atomic mass would be 1. So we can see by the definition, atoms that have the same atomic number but different atomic masses are called isotopes. So these two are isotopes of hydrogen because they have one proton in their nucleus. So it's as simple as that. And yeah, that's what happens when you have different numbers of neutrons. And it is not compulsory that the number of protons and neutrons will be equal. They'll be generally around equal. So just like in this case they are equal, here there is no neutron, so they are not equal. But the point here is, generally you will notice that there will be one isotope generally that will have an equal number of protons and neutrons, and there might be another isotope that has one neutron more or less, right? That is the basic trend that you might be you'll notice. But yeah, there's no hard and fast rule that the number of both of them will be always equal. It's just something noticed generally. So yeah, that's it for this video.